to bring this lab completion to an end was really very, very positive. So we could finally do some work and actually develop a team properly. And then we had a few weeks, I think it was ago, we got some photos taken for some press releases. And well, couldn't we do a virtual tour as they do for these real estate and houses? And of course, I got the answer, well, we've never done this before. And then Kira Haidt, who's a trainee in the photo office, I think, in the photographers here, she said, I can do that. Okay, you go. And you will see at the end the result of this. I think it's very, very innovative, very exciting. So you can then later take your own walk through our labs and see. So what's the purpose of this virtual lab tour? Well, it's for people to come and visit our labs when real visits aren't possible. Now, our labs have been open throughout the corona pandemic. I'm very, very happy about this. It wasn't particularly easy, but when I had these phone calls with our safety people, and at some point I got this answer saying, you just want to tell me that you should close your labs. And I said, no, I just want to hear that I can stay open. And so we could stay open. I was really, really happy because, of course, Corona came just as we had labs. And so you can come, we're open, but of course, many people can't travel right now. So it's possible to show, and also our future students and staff, they usually come from abroad. We don't bring people for interviews in person. And so it's also really nice for these future potential team members to have a look at facilities, what's there, what's the equipment, and also see a bit where and maybe how the team works. Also, the last 5 years, a lot of things we did is develop very nice methods and systems, because we have seen, and I also hear that from colleagues, often there's a lot of problems with experimental design. So we've had the privilege, and I think I have this privilege every time I move labs, to do things differently and better than previously. And so I think we have really developed some really nice processes and interface for data recording. So I think it's really quite nice. So here I will give you a bit of a description before the virtual tour, because the virtual tour is today guided, but normally it's not guided. And so we just put on the web also what's there. So what are our labs? So we got about 500 square meters, and then had to decide how much we put there, what we put there. And so that is what we came up with. We have a membrane preparation lab. I'm not really a membrane preparation person, but we made sure that this is humidity controlled, such that it's the same humidity, more or less the same year. The whole labs have a temperature range. They're not really air conditioned, but we have a range where we stay within. Culture, it can get quite hot in summer and of course quite cold in winter, although we have better heating than air conditioning. Then we have a membrane characterization lab, a membrane filtration lab, a radio tracer lab, analytical lab, process lab, a big cool room for our many samples, and some small bathrooms and kitchens. So it's designed really to interact, and I'm an experimentalist, so I was really quite pleased, or consciously actually put students, PhD students, in the lab with a desk so they can work near the experiment, and we can really interact a lot with others. So we have a nice meeting room where the other team is currently making sure everyone can get in who wants to be here today, where we have group meetings, postdoc meetings, seminars. We have a lot of interactions with the team, currently online teaching, of course, and video conferencing. We have the desks in the lab, as I said, which is cool for experimentalists. It's not so cool if you want to write in peace. And then there's shared postdoc offices, again, to enhance our interaction and be close together, which we couldn't have before. We have all laptops, so we can work wherever we are, whenever we want to work. And we're still carrying on the battle to get extra offices for PhD students and a much needed technicum. To take you on this tour, we have this membrane preparation lab, where we have basic equipment to make membranes. We are not membrane manufacturers. We are application people, environmental engineers, but we have a Dr. Blade now. We have a coagulation bath. We even know how to use it. We have an electrospinning equipment, which is interesting. That came out of a collaboration with India some years ago. A dip coder, a freeze dryer, a microtome for sample preparation for imaging, a sputtering device, and a centrifuge. And also in this lab, doesn't fit with membrane preparation, but we have a state-of-the-art LCM SMS that we're currently seeing if it can possibly challenge our radio tracer methods that we have developed last 20 years, and that I really still think is unbeatable. It's designed with humidity and temperature control, so we don't get the environmental interference with polymer production for formation. Then we have the characterization lab. Well, in there we have our standard equipment, contact angle, both the cell drop and captive bubble, the surplus, streaming potential, thermogravimetric analysis, so that we're kind of hoping one day to maybe couple it to a GCMS to look at what's being degraded in the membrane. Simple microscope, a bubble point barometer, sonication bath, and really what we're trying to search there is what that guy had said, the relationship between structure morphology and property relationship performance. It's really not easy at all, especially not with nanofiltration. Filtration lab, well, that's where it gets a bit closer to home, where we're excited. You see here there's computer screens, so every system has a lab view, usually for data acquisition, sometimes for control. We can control the temperature in our systems between 20 and 40 degrees. In fact, it's not true. We can go lower, we can go to 10 degrees. We have stirred cells, as we have always done, have always had. We can use them at constant pressure or flow operation. We have cross-flow cells for ultrafiltration, we have nanofiltration, and we have what we call the micro cross-flow systems, where we have systems for 2 square centimeters of membrane. That's important when membranes are new and we can't get a lot more. We couldn't go much lower because we felt the water was evaporating before we could catch it. And we have also these micro cross-flow filtration cells for photocatalytic membrane experiments, where we have a quartz cell where we can bring the light into the system and we can operate that cross-flow and dead end. We have a solar simulator, that's for simulating sunlight for photocatalysis. We have usually data acquisition or control with LabVIEW and some diffusion cells. So important here, in the last few years, we have paid attention to build systems that have realistic hydrodynamic conditions, similar to spiral wound conditions, but with 2 centimeters square. And I think that's really important to make sense of the results later. Then we have our radio tracer lab with 2 scintillation counters, and we really can get the limit of detections much less than what is said here. We can get last I see 0.5 nanograms per liter for steroid hormones, with very small samples. It's about 1 milliliter we use there, and that allows us to have absolutely amazing mass balance, very, very accurate results. And that is what allowed us 20 years ago to measure breakthrough curves in nanofiltration. We have then extended that. That was Roman in charge here. Roman spent crippling year and a half setting up a ultra high performance liquid chromatography separation with flow scintillation analyzer. We can now actually do radio tracers in mixtures, so different hormones that all have the tritium label, and we can see if a compound is degraded or not. Works brilliantly, but it was enormous effort, of course. Plate counters, incubation shaker for absorption studies, so really here super small sample values, very low detection limits, and no error, because of course our LCM SMS, I think the error will be as big as the effects we want to see. The analytical lab, well, it's a kill by Rolls-Royce analytical instruments that we don't know how to operate, to put it in reality. Now, the reason we need these machines is because we generate a huge amount of samples. We do experimental work, and experiment typically generates 10 samples. Roughly on average, we have 50 or more experiments for a paper or for a study or a master's thesis. So that gets to somewhere between 500 and 1,000 samples by the time you have calibrated and repeated a few things for each study. So there is simply no colleagues who are willing to put up with this level of numbers of samples. So we have to have our own instruments. And of course, we don't know how to really operate them well. We certainly have no permanent staff. So essential part of our training is that each team member has one instrument responsibility and a second as a cover. And so learning to solve problems, troubleshoot, dealing with suppliers, proper calibrations, quality management is really an essential part of our training. And I think everyone will probably agree, very exhausting and challenging, but it's working very well now. Now, not only this, we also have started to become masters of instrument coupling. So of course, we have UV spectrometer or total organic carbon analyzers, which we also can put in line in our membrane systems. We then have ion chromatography and inductively coupled plasma mass spectroscopy, which we couple, for example, for arsenic filtration. The flow field flow fractionation together with ICP-MS or the liquid chromatography organic carbon detection to look at interactions between contaminants and organic matter. And of course, calibrating this. It's a great job and it's working. So, we have fought for many years now to get things working. It's working. So I think we're currently in paradise. Of course, there's ongoing problems with these instruments, but it's really very cool. And I think here is a very big invitation also if anyone would like to join and use some of these instruments. We're not using them all at full capacity, so there is room here for collaboration. Then we have the process lab. Bench scale and small scale pilot systems. There's Meran sitting in front of me. He was very happy yesterday because he bought a system and he measured the lift and he said the system should be the same size as the lift. In fact, it didn't. So they managed to get it in the lab yesterday. I think we have learned something again. But what's in there is various devices, more small systems as in the filtration lab. There's an electrochemical membrane system, brand new. There's a batch electrolysis system, single pass ED as of yesterday, super instrument thanks to Hans-Jürgen Rupp from Deucum. And generally a step up, so very tiny or small lab pilots, and also what for cross-flow filtration, nanofiltration, ultrafiltration, one powered with direct current, one with alternating current. So this goes in the direction of coupling with renewable energy. We're still fighting for a technicum so we can work on larger scale, but in the meantime, we have border mobile solutions, so very cool. Only about a month or so ago, we got a Land Rover Defender, and that the intention was to put systems on the back of it. We're now thinking, well, maybe we need them on a trailer to not maybe damage the car with salt water so much. But that's really there to go on excursions for mobile working with our autonomous decentralized systems. And really what is needed in student training or staff training, we need field work as a tool for students to experience the organizational skills, to being in the field and actually dealing with real problems. So we're looking for some cool adventures in Europe and looking at my North African colleagues. Maybe we get invited to Morocco. So I think there's things to be done. The yellow here, I put that in. Pia mentioned uranium, which was kind of curious, but we did actually find quite a lot of uranium in some German waters, and so we can't wait to work with it. So then we have in the corridor, you will see poster exhibits, and we can of course change these posters. There's 22 slots. Idea is that everyone working in the team has their poster, so if someone comes visit, they can show off what they do with the poster and the experiment. We have won 3 prizes last year. 2 at ICOM, 1 at with Damia Barcello at the workshop on analytics. So it's very nice. And you will later this afternoon see a presentation of selected posters, 10 of them, I think, in 10 minutes. That's pre-recorded, so you'll see that. Okay, then what we have is, those who know me, I usually have a camera hanging around my neck. So there's a permanent exhibit of photos in our lab that show the motivation, what we do, some of the most memorable field trips in Australia and Africa. Usually the memorable increases afterwards once the hard work is more in the forgotten memory. And working in international development means we need the best of minds. So it's people who can master the science and technology under normal circumstances and are able to adapt this knowledge and skills to the harshest and most unforeseeable circumstances. So problem solving as you go along, things that just don't work out when you get there, and that really needs the best of people, not just those who want to help somewhere. So that's something which we constantly try and find, those kind of people. Photos remind us of our purpose. And especially as it is in research, when the going gets tough, when the experiment doesn't do what it wants, when we don't get our way, when the work is just a bit harder than we expected, and the feedback, once again, I'm good at that, harsher than maybe it needed to be. So it's been fascinating the last many years to travels and fascinating people and cultures and amazing environments. And I really, really hope we can get back there very soon and go travel and meet people. So all of this, I have a dream, safe drinking water for all children. Here are some of the examples of our exhibits. So the Land Rover in Africa, And, you know, two encounters that I've had here, you see the guy in the bottom, water we can't do without. I mean, can you imagine someone standing in front of you with this t-shirt on, which usually, of course, is a second-hand t-shirt, and then another occasion, dreams do come true. On the left, some crazy kids who usually argue about who gets to take the nice water sample. If Tony is still with us, you can see Moana there. Now that was in 2012. So she is now a little bit bigger, and people have mentioned that I carry people in a backpack, our kids normally in a backpack, and when I give a talk, I can't carry any of them anymore. So with that, we come to the virtual tour, and your guide today is Lee Estrelado. So enjoy the tour.
Hello, everyone. I wanted to thank you first for all being here today for this really interesting day of talks. And thank you, Andrea, for all of the nice information on our lab. So as we mentioned, we had a virtual tour produced by Kira Haig here at the AIT. So I would like to share with you the tour, and we will also link this to you shortly in the chat so you can all get access to it in the next hours and days and whenever you want to take a virtual tour of our institute. So I will share this page. So this is our virtual tour. We start outside our institute so you guys can see the environment in. It's pretty user-friendly, so you can just click your mouse and drag around, see where we are in the KIT North Campus here in Karlsruhe. You'll notice that some objects have an eye on them. This means that you can click on them for further information, and it brings up a picture of our nice new vehicle here. But the real stuff we'll see inside. So we're going to click on this circle to go into the institute. So this is right outside our institute front door. You already see here some of the photo exhibit pictures hanging on our walls. Again, this is a virtual tour, so you can always click around and drag and see whatever you want to see. Now we'll enter the institute, our corridor. On the hallways, you'll immediately notice we have posters hanging. These are the poster exhibit that Andre just mentioned in the previous PowerPoint. So you can also click on these and get a picture of the posters that we currently have hanging in our wall. You can even scroll to zoom and then drag and read everything you would like to see on the posters. And to escape, you can just press the X button and get back to the virtual tour. So we'll quickly go through the labs now that we just discussed. So here, if you need to know the name of the lab, you can always look down. So this is our membrane preparation laboratory. Again, you can scroll around and see almost all the devices we have in the room with this great 360 view. You can also zoom in a bit if you want to get a better look at something. Zoom back out. Next, you can head into the hallway to continue to see more labs. So again, we were just in the membrane preparation laboratory here. We could continue down the hallway and see the next laboratory, which is here, the membrane characterization laboratory. Head back out in the hallway again, and then check your orientation, make sure you're still heading down. So to go further down the hallway and walk virtually, you're going to click on the arrow in front of you, and then this brings you down the hallway to the next set of laboratories. So we have this membrane preparation laboratory again, and then the next lab, which is this big open process laboratory where we have a lot of our PhD students sitting and working, as well as a lot of equipment, as you can see. So again, we will go back on the hallway. We will jump into this next lab here, which is the membrane filtration laboratory. So you can see we have various devices over here and equipment. And you can scroll through and see everything. There's also information you could find on our website, which Andrea just presented, that describes this equipment more in depth. So if you wanted to, you can do this virtual tour and look at our website to get a full view of what we have going on in the labs and the equipment that we have. These are the last two labs here. So starting off, we'll go through the radio tracer lab. So you can see all our equipment we have here. Again, more description on our website if you need. And then our final lab will be here, which is the analytical lab with, again, a lot of more really interesting equipment that we have. For for use for the PhD students and postdocs and anybody working with the Institute. Finally, we have on the right and left the two postdoc offices. So this is where our postdocs interact and do their work. It's a really good space. Everybody can easily communicate with each other, and this is really helpful. Again, and then just across the hallway, we have our second postdoc office with more nice pictures from the photo exhibit on the walls, and again, a very good interactive space for communicating and sharing ideas with each other. Then finally, at the end of our hallway, we have our conference room that we discussed earlier, our meeting room, conference room. It's really an all-purpose room that we have to use for a lot of things, such as online teaching, presentations, and then just general group meetings. So this room is really used a lot, and it's very useful to our team. And again, many pictures to look at if you guys are interested and zoom in on. Finally, back out in the hallway, we will go into Andrea's office, which is where we are sitting right now. So this is the room we're in. You guys probably can recognize it from the background. But yeah, this was the last office. Quite a nice office. For the virtual tour, you guys can find it at the link that will be shared in the chat. And it's also available on our website. You can go to the homepage and scroll down. If you have any questions, of course, feel free to email our conferencing email address, and we can help you guys out with any technical difficulties you have or questions. Now we welcome you to go check out the lab tour on your own, and for a few minutes, click around. And again, this will be available to you guys, everybody, whenever you need to take a quick view of our institute. I will now pass it back to Andrea. Thank you guys for everything.
Thank you, Lee. So I'm very excited about this tour. I think we will stop sharing it though, because you can look at it online and move on in the program.